Hi, everyone. My name is Ryan Harter, and going to talk about multi-platform. So a lot of us these couple days were talking about and experimenting with multi-platform, and in my experiments, one of the surprises when I first started working on multi-platform stuff was how important architecture was, the architecture you choose for your app, and the implications that has and those decisions have on multi-platform. So we're going to talk a bit about that today. So maybe you've got an Android app, an existing Android app that has a real, nice, great, clean architecture, well-defined, or maybe you've got two apps that have a similar, matching, clean architecture. The goal of sharing code, though, is to reduce the amount of code you have to maintain, and so we'll just look at this app, Kotlin multi-platform. The process to make this a multi-platform app is you just pick one of your apps, you convert it all to multi-platform, right? And then there you go, you have a multi-platform app. Throw the other one out. I would argue, though, that it's really important actually to sort of keep the top view layer in like the native framework, whatever that is. So that changes the story a little bit. Then you end up with a little bit of not shared code, but everything else is shared. And again, we're done. But we're really not, right? That's what the samples make it look like, just make your whole app this way. But for most of us, probably, we have a lot of things like existing apps. We already have something on other platforms, on iOS maybe, web, whatever that is. Or we have teams, right? You have an iOS team. They really love their Swift. And that's awesome. Swift is great. But so what we're really looking for here is a more reasonable solution to get to multi-platform. So that's what we're really going to talk about today. And the first step in getting to multi-platform, converting your existing app to multi-platform, is to modularize. It's been a popular thing in the Android community for several years. If you're not there yet, just a real quick thing, modularizing your code, aside from all the other benefits of build time and everything else, a modular code base is less risky to convert to multi-platform. You don't do it all at once. You can do one module at a time. It's also important to have a clean architecture, and I say clean with air quotes, lowercase. This isn't like the Uncle Bob clean TM architecture. We don't really care. What's important here is that we have different layers that are not super interdependent. Not a lot of dependencies between the modules. I use MVI, but the other thing's inversion of control. As we're converting things to multi-platform, we really need to reduce dependency by making sure things aren't reaching into other things to get what they need. So providing dependencies via constructors, via a service locator, dependency injection frameworks, whatever that is. And we want to minimize our platform dependencies. So this is something that's not really unlike a lot of what we do in trying to improve our build times and that kind of stuff. A lot of us, I at least, try to make the, sort of the inner layers not have an Android dependency, just make it just Java, just Kotlin, whatever that might be. And limit those dependencies to the view and the repository. The repositories, on one end, need to talk to system services. They need to talk to, notification services, location services, that kind of stuff, which is platform dependent. And therefore, it makes a lot of sense that talks directly to the platform. And the views use existing view frameworks and that are provided by the platform. So it makes sense that those have platform dependencies. But what goes in the middle of the app between the repositories and the views that might be a platform dependency? An example of that is live data. That's something, love it or hate it, a lot of us use live data in my app, Pigment. We use live data pretty heavily. What's interesting about live data is that it actually exists to solve a platform-specific problem. iOS doesn't have all of the life cycle difficulties that Android has. They have different problems that they have to deal with. Same for web, same for desktop, all of that. So live data doesn't really have a real place in multi-platform apps. So real quick, we've seen this at conferences over the last few years, but let's say we're starting out with this big monolithic app. We want to modularize. How do you do that? Start out with your low-level dependencies, things like databases or APIs, that kind of stuff. You just kind of pull it out into its own module. The monolithic app will depend on that module. Things sort of happen normally. Once you kind of get that lower layer, then you can move into things like repositories. You can abstract that stuff away. And this usually, if you're going from a monolithic app, involves more code changes, because instead of all of your view controllers or all of your activities or fragments or views talking directly to the database, because you copied and pasted that sample code, they're going to abstract that into a repository. Then we're going to abstract it even further into a feature layer. This might be a view model, presenter, whatever you want that to be. And then you continue doing that until you eventually have a nice architecture where things are separated. So that's sort of step 0. Everything else in the talk sort of depends on having that type of structure. So that was a quick intro. Now that we're through that, we can get to multi-platform. So, maybe you've got just an Android app that you're ready to move to another platform, something like that. Or maybe you have an Android and an iOS app, or desktop or web. Platform is sort of irrelevant here. That have different architectures. In this case, my example here was an iOS app that's monolithic, but it could be just a different architecture, because things grew over the years. Or maybe, and hopefully, you've got apps on different platforms that share a really similar architecture. Everything's sort of re-implemented, but the architecture, the high-level thing, is the same. And let's hope that's what you've got. And are just looking to reduce the amount of code you have to write, the maintenance that you have to take care of, bugs introduced on one platform, or you implement the same feature on 2 platforms, and things were interpreted a little differently or missed or something, so things are slightly different between the platforms. So those are kind of, as I was sitting in my basement thinking about how to do this in my experience, those are kind of like the 3 main places that you might be when you want to go multi-platform. So what I want to talk about is how to get from these places to a multi-platform app. So we'll start with the single app. You want to port to other platforms. You only have an Android app at this point. So this is really like the easiest scenario. All of the functionality needs to be replicated on the other platform. But it's nice because you can really start anywhere. It doesn't really matter. You don't have the baggage of another platform that you're trying to update or anything like that. And so this is really similar to if you're just going to make a new app. How do you start? For me, pick a feature, and you just implement that feature. And then in our case, we're going to convert it to multi-platform. And then you set up your other platform, the app, to just depend on that feature. That's fine. You test it. Everything's going great. And then you just move on to another feature. So now we're going to move on to the account feature, and then you just update the dependency to point at that. All of the time while you're doing this, your original app is sort of a test bed, right? You can upgrade things to multi-platform, and you can use the original app to make sure that functionality still exists, that things are still working as expected, while you implement this on the other platform. So, like I said, that's the simplest scenario, and hopefully you're in that case, but I'm not. So maybe you have like multiple apps on different platforms already, but they don't share an architecture. They're very different. And depending on that architecture, that's kind of really what determines your process. But it's, in a lot of ways, really similar to the modularization story. You have a monolithic app, you want to modularize, and you start at the bottom and work your way up. What's nice about this is that you can convert to multi-platform as you modularize, or as you work through this new app. So you don't have to go through step 0 and then go to multi-platform. Again, pick a feature you want to convert, and then just start at the bottom. Work your way up. So in this case, just like modularization, we'll convert the auth API to multi-platform, test it, make sure everything's working on the original app, and then just make the other app depend on that. Use that instead of whatever it had. So it gets to shrink a little bit. The next lowest dependency is the database. So we move on to that. Same story, we update it. And then you can kind of just move up that dependency tree. So you maybe move to the user repo then and update your app. You'll notice, in this case, the iOS app, we added the database. A lot of things depend on the database. So, your iOS app in this case is going to still have a hard dependency on that database, but it no longer needs to know about the auth API because we abstract that with the user repo. Move on to the login feature, convert it to multi-platform, test, everything's working, hooray, we update our iOS app to use that. And so in this case, both of the apps, iOS and Android, are implementing the UI, but they're talking to the view model that's inside that login feature. And again, now that it's using the login feature, it doesn't need to know about the user repository, and it gets to shrink just a little bit more. And eventually, you do that for the other features and everything, and now you've got 2 very thin, lightweight apps at the top that their job is to provide UI and manage dependencies, decide how to create and provide dependencies. So they're relatively lightweight things. So from there, we're going to go on to my favorite part of this, which is having multiple similar apps. And this is something at my company, Pixite. This is the boat that we're in, right? We have 4 iOS engineers, 2 Android engineers. And so what that means is that a lot of times, on iOS, they're sort of developing things first because they have more resources. And we get to it a little later, so we can sort of steal some architecture, and then we make changes as we need. But that sort of leaves us at the end of the day with a really similar architecture. And so there's a lot of choice in the approach that you take to migrate this type of thing to multi-platform. One thing you can do is start with new features. If you're coming out with new features for your app, introducing new things, just make those multi-platform. Another option is a vertical migration, and this is really similar to the other cases. You can also do a horizontal migration, and this is the one that in my opinion, is sort of the best approach to get the most bang for your buck. But the choice really depends on your existing architecture, your teams, your roadmap, like all of that kind of stuff. What's nice about this is that all of these approaches, it's not like the samples for multi-platform make it look, where you just rewrite the whole app in multi-platform and ship it. That's really risky. So you can kind of do all of these with small PRs over time. You can test, you can use experiments to roll things out to small portions of users, all that kind of stuff. And really let this grow. So take a look at the new feature approach. This one's pretty simple. When you're adding a new feature, say we want a subscription feature, implement it in multi-platform. And it's going to depend on the platform-specific lower layer. In my case, it's repositories. You might use use cases, whatever that is. And we'll talk a bit about how that dependency works and the implications there. But from there, you just update your apps to depend on that new feature. Now you've got a multi-platform feature to start out. Well, that looks really simple. There's a little bit more to it because you're depending on system stuff. And so if we can zoom in a little bit on the subscription feature and take a look, the user repository, since there are multiple platform-specific implementations, in our multi-platform code, we've got the common, we make an expected interface for that user repository, and then we'll have some platform-specific implementations. Sort of the trick here, so you don't have to update all your dependencies, is to type alias. So if you have the same type of interface or protocol, you can just type alias on both sides, and that way, when this is actually compiled for native, for iOS, the instances of this multi-platform user repository are effectively just going to be replaced with the platform-specific one. So this means you don't even have to touch your other layers, your user repository in this case. If that's not an option, maybe the implementations are similar but not quite exact, that you can just do this simple thing. You can easily just make a thin wrapper. And I've actually done that for some of the Firebase SDKs. If you're querying the real-time database, they're really similar, but not quite exact because of different platform limitations. A thin wrapper to use the underlying SDK works really well. In this case, what I do is I include that in the feature itself, because eventually, once you migrate your repository layer, that'll just get taken out. It isn't important anymore. So zooming back out, that's it. That's super simple case. We add a new feature. It's multi-platform. So one last thing to mention is that is a really good way to sort of dip your toes into multi-platform without going all in. You don't have to convert an entire app. You don't have to wait for things to bubble up to really see the value in it. You can just update right there in the middle. So one of the other approaches is the vertical migration. And this one, again, similar to the others, what you do is just pick a platform, start at the bottom, and pick something without a hole that is nice and isolated, and convert it to multi-platform. All right, you do that on one platform, pick your platform, make sure everything's still working, all your tests are still passing, everything that depends on it is still working as you expect it, and then you just update the dependency on the other platform. So in this case, we started on Android, we update the iOS app to now depend on this multi-platform version. And then pick the other, another low level, in this case the database, update it to multi-platform, run your tests, all of that, and then just update the dependencies on both platforms. And then you move up. So this is vertical, so we're just going to move up, move into the user repository. In this case, we're going to start on the iOS side, because it doesn't really matter. Update the dependency, same thing. It's a pretty simple idea. And you do that, and now we have like a whole vertical feature that's all backed by multi-platform. And as you move on to other features, to get to this full, complete multi-platform story, it becomes easier and easier because you have more and more lower layers that are now converted. So now we get into the horizontal approach. And this, what I've found in my experimentation is that this is sort of what I would say the air quotes best approach, because the idea here is that if you have a really similar architecture, instead of starting from the bottom and working your way up, start from the middle, which sounds a little silly, but bear with me. So looking through this, if we sort of stack these two, you can see the architecture is really similar. So the same with the vertical approach. Pick a feature you want to convert and convert it, but start at the feature layer. In my case, that's where a lot of my complex business logic is in the feature layer. If you use use cases and that's where your complex business logic is, start there. But the idea is to start wherever your most complex business logic is, because that's where you get really like the most value out of multi-platform. Using a multi-platform database is nice, but if you're querying that database and then doing calculations and conversions and all that kind of stuff with the data, you didn't really save a whole lot. So this is where this is really helpful. So once that's converted, you update the dependencies and then move across the layer. So, finish out all of the feature layers, get all of your really complex business logic, and then just move to the next layer, wherever your next most complex logic is. So in this case, at this point, we don't have a completely platform agnostic code base. We're still duplicating some code, but we're basically getting the most value out of multi-platform. And then, as you work through things, you can update the other layers, and this helps for some reasons that we'll get into shortly. But that's easy to talk about, but I want to kind of take a step back and talk about how you start that. So the idea of sort of starting a multi-platform conversion in the middle seems a bit unintuitive, but let's zoom in on that feature layer and take a look at what that really means. Before we look at code, just the high-level idea here is that the challenges with converting your interior layers to multi-platform is that these layers are interfacing with more platform implementations of other layers, right? So you've got the views at the top, which at the end of the day, you're going to have to interface with anyway. And then you've got the repositories or use cases, whatever it is, sort of at the back end of this layer, which, if we're going horizontally, is still a platform specific dependency. So we're connected both at the front and back end, and the biggest challenge with this for me, when I was doing it for the Chicago Roboto app, was trying to figure out how to observe values. We have things like live data that we use, or RxJava. Those are not, don't exist on both platforms for obvious reasons. We've got cool things like coroutines and flow. You can't use those outside of Kotlin because you can't call suspending functions. So that was sort of a thing to figure out. So moving into this, this is sort of the way I kind of think of that feature layer. At the back end, we've got the repositories that we're connecting to, usually multiples of them. And then at the front end, we have the view. In an MVI approach, which I like to use, there's only a few outlets here. You might send data, observable data, like a view state or view events. You take in view actions, something like that. So it's kind of limited. But everything in the middle, that's where your multi-platform lives. That's the stuff that's converting your database values to view values and deciding, if an error happens, what happens with the state? Do we navigate to the login screen? Like that's where the complex stuff is, and that's the multi-platform portion. So that sort of brings up the question of how do we interface with all of this stuff? So looking at the repositories first, a real common case is just like callbacks. On both platforms, a lot of SDKs, a lot of built-in frameworks use callbacks, and it's super easy, right? There's not a whole lot there. There are a few limitations. Later on, once you update that back-end layer to multi-platform, it gets a little simpler because you can use coroutines sort of all the way through. You can use flow. And a side note, I couldn't find an emoji for flow, so this is some sort of stream emoji that I came up with. But yeah, so you can use that all the way through once you update. Big caveat, can't call suspending functions outside of Kotlin, so everything sort of needs to be Kotlin in order to use that, which brings us to the view. The view in my architecture is never intended to be Kotlin on other platforms. On Android, it will. View actions, stuff that comes into the view model, that's simple as a function, right? No question there. But what about the view state? That's something we want to be observable. And we want to be able to, simply just, register something that can listen to this. Callbacks is a way to do that, but we've kind of moved on from callbacks. Would rather not if we don't have to. In the Kotlin world, multi-platform or not, we can use flow, right? We can do that, but any platform-specific implementations, if you're calling it from Swift or C# or whatever. That's not really an option. So what do? Something that I've been experimenting with, and it's not quite ready for release, but promising, working really well, is reactive streams. And so a lot of us use, or maybe used 2 years ago, RxJava, that type of thing. It's relatively familiar. Reactive streams, if you don't know, sort of sits one layer up or down from RxJava. It's sort of an interface that RxJava interacts with. So reactive streams includes 4 interfaces and no implementation. It's like subscriber, subscription, publisher, and the other one. But what's important about it is that if you use reactive streams, it interoperates with, or if you use RxJava, it interops with reactive streams. You can easily convert a publisher to a flowable, observable, whatever you want. If you use live data, it works with reactive streams. You can easily convert a publisher to a live data. If you use, I think it's Reactor or something like that, the other Rx library, that works with reactive streams. So there's already this sort of existing body of stuff that works with reactive streams, and it's very lightweight. So that's what's nice about it. If you use coroutines, it works with reactive streams. There's a JetBrains first-party library that you just add, very lightweight, to convert a flow, a channel, whatever you want, into a publisher. So what I've been looking at is making that multi-platform. So what does that look like? Here's an example. This is the subscriber interface from reactive streams. Like I said, super simple. And I think this is actually the most complex interface in reactive streams. So what I did is basically make it an expected implementation, and then on the JVM, that trick I said before, just type alias it to the built-in org.reactivestreams subscriber. In that way, if you're working on the JVM and you're using live data, RxJava, Reactor, any of those, they work out of the box, right? You don't have to do anything. We're not re-implementing RxJava because that sounds like a nightmare, and we don't need to. On iOS, it's a little more complicated because they don't have sort of a standardized reactive framework. So I just made an actual implementation of the, not implementation, an actual interface of that subscriber, and then an implementation, a class, I call it a block subscriber, just to make things a little easier so you don't have to make your anonymous classes and all that, where you just pass in blocks, which, if you don't know, is iOS lingo for Lambda. You pass those in, it makes the subscriber, handles the subscription, all that kind of stuff for you. Again, this is super lightweight. And what's nice is that, in my implementation, like I'm basically using flow, using coroutines behind the scenes, and this is just at the edge. This is just at the interface. And so we don't need all of the power of RxJava. We don't have to like re-implement all of the operators, like all of that, because what we're really looking for here is subscriptions. Sorry, there's the block subscriber I was talking about. And then what I ended up doing is in Swift, I actually wrote a very lightweight piece to sort of help with this, to make it very intuitive for the iOS engineers. It's just an extension function so that, it will construct the block subscriber for you. No big deal. So what that means is that we can use reactive streams for that observable portion. And so let's zoom in a little bit on sort of that interior part, that view model. So what that looks like for me is I have a view model interface which has a flow. That's the view state, right? The Android implementation is just that, right? It's super simple. But I don't want to have to like go through all of the reactive stream stuff for every view model that I have, all that kind of stuff. So the iOS implementation just adds a method to that interface, which you can do in Kotlin, can't really do in older, Android Java, that is just going to convert that view state to a publisher. This as publisher method, this is part of the coroutines reactive streams library straight out of JetBrains. That's sort of a lie because I had to update the package so it would use the multi-platform reactive streams, but not important. It's same code, straight from JetBrains. And that's the only thing we really need to add. So now in our view model code, we don't need to think about reactive streams. iOS just gets it for free. So here's an example of the view model. I've got some flows. I've got a broadcast channel, that kind of stuff. I'm using like the actual coroutines combine function to, and other operators. There's some other flatmap concat, other operators in there. That's all out of coroutines. JetBrains manages that, nothing I need to worry about. And expose that, override that view state method. And then on iOS, we get the reactive streams implementation for free. On Android, just use the flow. No need to go through all of that conversion. But you can see here, there's that extension function. So I just subscribe to that reactive stream. It's going to create the block subscriber and do all of that sort of stuff. So that's a real simple way to like share that kind of stuff across platforms. So, zooming out, we go back. This is what the view model looked like. Zoom out a little more to our feature layer, and that's sort of how we convert that first feature to multi-platform. From there, we move on. We convert everything else. The world's a happy place. And so that's sort of how you can convert anything, right? Wherever your starting point is, that's a way to get to multi-platform without throwing out all your existing stuff, making a really risky update and not having to wait forever to really reap the benefits of multi-platform. And with that is my guide to effective multi-platform architecture. If anybody has any questions, let's chat off to the side so the next person can get ready. But thank you very much.